Hello friends, welcome to PCM Corner YouTube channel. In this video, we are going to revise dual nature of radiation and matter, a chapter of NCRT class 12, and for JEE and NEET syllabus it is included in modern physics. So let us start with some theoretical information which are very useful and important for NEET aspirants, and it is not very much important for JEE aspirant, but we should we should take it as information and study it. The first point, around 1887, the wave nature of light was established. from from 1887, the wave nature of light was established. In 1885, the X-rays were discovered by Roentgen. Cathode rays were discovered in 1870 by William Crook. This all information you should remember it. The fourth point, the cathode ray in the year of 1879 was found to be a fast moving negatively charged particle by J.J. Thomson. J.J. Thomson found the speed of cathode ray to be equal to zero point 0.1 or zero point 0.2 times the speed of light. That means 0.1 or 0.2 times 3 into 10 to the power 8 meter per second. The E by M value of electron is found to be 1.67 into 10 to the power 11 coulomb per kg. Further, it is found that the E by M is independent of material used in glass tube or the gas included in tube. So for cathode rays, an experiment was done, and in that experiment we can use any of the material and any of the gases, and the result are same for both. In 1897, J.J. Thomson named the negatively charged particle to be electron. In 1930, R.A. Millikan performed oil drop experiment, which is very important. Why it is very important? Because by that experiment only we can conclude that the charge always remain in quantized form. That means charge on a system or charge on a particle is always integral multiple of 1.6 into 10 to the power minus 19 coulomb. So here we complete some theoretical information about the chapter. Now we will study some important definition which are very helpful in calculation also. So the first definition is work function. What is work function? A certain amount of energy required to be given to an electron to pull out from the surface of metal surface. As we all know that metal surface have plenty of electron, but this electron cannot eject from it by their own way. They need some energy to pull out. So the minimum amount of energy which is required to electron for ejection is called work function. The next point, it is measured in electron volt. So the unit is electron volt. And what is the definition of electron volt? So it is 1 electron volt is the energy gained by an electron when it has been accelerated by a potential difference of 1 volt. And 1 electron volt is equal to 1.602 into 10 to the power minus 19 joule. For calculation we can use 1.6 into 10 to the power minus 19 joule also. It is important factor you should know for calculation. The next point is it depend upon the nature of material. That means work function vary with the material. For lithium it is different, for cesium it is different, for sodium it is found to be different, and in periodic table it is least for cesium. That means cesium when light is bombarded on the cesium, the electron can easily eject from it. Then the last point, the energy to the metal can be given in following ways. The first way, thermionic emission. When the metals is kept in such when the metal is kept in such temperature that by gaining some energy the electron can eject, this form of energy supplied is called thermionic emission. The second way in which energy can be given is field emission. That means by applying electric field across the metal, so the electron can easily eject. The third and the last point is photoelectric effect, about which we will study in next page. So let us study the photoelectric effect. When appropriate amount of energy given to the metal surface, the electron through metal gaining energy come out. So as we give the appropriate amount of energy, it is defined for one element that by applying this much amount of energy, the electron will eject out. So if we applied that much amount of energy, the electron will eject from the metal surface. This energy in the form of light contain energy packets known as photons. It is important term that photon. What are photons? When energy is supplied to metal, the energy is in the form of energy packets. That energy packet supplies the energy to the metal electron, so that by gaining that energy, the electron will eject from the metal surface. The next point is photon are neutral and massless particle. The rest mass of photon is zero. That means that are neutral in nature, and when they are put in rest, they have no mass, but when they have some velocity, they have momentum as well as energy. Here are some important calculation for finding energy of one photon. Dear friends, it is energy of one photon, that when a photon of frequency mu is bombarded on the metal surface, it has an energy equal to h into mu, where h is Planck constant. The second point, that when wavelength of light is given, then we use the formula E is equal to hc by lambda for finding the energy of electron. It is energy of one photon, dear friends. The next point, the shortcut formula we can use for calculation of energy when the wavelength is given in nanometer, that energy is equal to 1240 electron volt per lambda. Lambda is wavelength of electron. Wavelength we put in nanometer, so that from denominator and numerator the nanometer and nanometer cancel, and energy we get in electron volts. The second point, for the calculation of momentum of an photon is given by h by lambda, and from the above equation we can put h equal to e lambda by c. So by cancellation of lambda, we get momentum of photon equal to E by C. So we get two formula for energy in terms of frequency, in terms of lambda, and for momentum we get two formula as energy as P is equal to h by lambda, and P is equal to energy of one photon divided by speed of light. Now we come to very important part of this chapter, that Einstein photoelectric equation. What is this equation? What it tells, that kinetic energy maximum of an electron is E minus phi. E is the energy of one electron and phi is the work function for that material. Let us discuss about this equation in detail. That according to this equation, we cannot find the actual kinetic energy of an electron, but what we can find is the maximum amount of energy this electron can have. It is called maximum kinetic energy. That means if someone asks you to find kinetic energy, you can not find it by this formula, but you can only find the maximum kinetic energy it has. That means in maximum kinetic energy, we will only consider that energy is not wasted in any collisions. We find it as an ideal kinetic energy an electron can have when it is bombarded with E and having work function equal to phi. So actual kinetic energy of a photoelectron can vary from 0 to kinetic energy maximum. It can have any value from 0 to kinetic energy maximum. So the formula can be further simplified as kinetic energy maximum is equal to hc by lambda minus phi, or kinetic energy maximum is equal to h mu minus phi. So we all should remember that by this formula we can find the maximum kinetic energy only, not the actual kinetic energy. Let us discuss further more important points. Just a minute, friends. So we come to the next point, the threshold frequency. What is threshold frequency? It is the minimum amount of frequency that is required for an electron to eject from the metal surface. For ejection or for threshold frequency, we can consider that when energy is just greater than work function, the electron will eject out and have a minimum amount of kinetic energy, but it will eject from the metal surface. So we write the equation E, that means energy of one photon is greater than or equal to phi. From that we will use the formula of energy equal to h mu greater equal to phi and mu greater equal to phi by h. So from this we get a value phi equal to phi by h, and for minimum case we will consider phi minimum is equal to phi by h, and we tell it equal to mu naught. Mu is here frequency, my dear friends. The formula kinetic energy maximum is equal to E minus phi or h mu minus h mu naught. Here we can take h as common and get mu minus mu naught. That means actual frequency minus the threshold frequency. Now very important, the graphs are very important for this chapter, and the graph between kinetic energy and frequency we can find as it is nothing but a straight line with slope h and intercept minus h mu naught. This is a straight line plot. We plot this in this manner that it have a slope equal to h and intercept on negative y-axis equal to h mu naught. Here you can think that how kinetic energy can be negative. So this is not the case. The kinetic energy of a particle cannot be negative. So we will draw the graph in this manner that in negative y-axis we represent it by a dotted line, that in this region the electron will not come out because kinetic energy cannot be negative. The next important point, the threshold wavelength, the minimum amount of wavelength which is required for ejection of electron from the metal surface. For that also we will use the same equation, E is greater equal to phi, and we will now use the formula in terms of wavelength. Hc by lambda greater equal to phi, and lambda is less than or equal to hc by lambda. We will change the sign of inequal. We will change the equation like that, and from here we get lambda minimum equal to hc by phi, and we represent it as lambda naught. So for the kinetic energy maximum, the formula E minus phi, here E is hc by lambda. Lambda is actual wavelength which is bombarded on the surface, and lambda naught is the threshold wavelength which is required for just ejection of electron. So as we plot the above graph as y is equal to mx plus c type, we will represent this equation in the same manner, that kinetic energy and 1 by lambda graph having a slope equal to hc and intercept equal to hc by lambda naught. In this graph also kinetic energy cannot be negative, so for that reason we will represent the negative axis as dotted line. So here an important note for you guys, that on increasing intensity of radiation, number of photon increases but energy of photon remains same. It is very important, the questions are asked from this knowledge, that by increasing intensity we cannot change the energy of one photon. We can do just only increase the number of photon which are bombarding on the surface of metal. We will discuss in further lecture how we can relate it with various quantities in this unit. The formula for intensity is power divided by area, and the unit of power is watt, and for area it is meter square. So number of photon, and this is very important equation, the questions are asked from this equation, that number of photon eject from the metal surface is equal to power of this device divided by energy of one photon we are applying to it. So these are very important equation, you should remember it as it is, because the question will come from this topic also. So here we conclude the lecture or video with this knowledge, and in further videos we will discuss further information about this topic. Till then, if you like the video, please do subscribe